Alright, welcome back everyone. I am your host, Geology Journeyman, and today is episode 1 of Field Geology Friday. The basics of field geology is today's lesson. We're going to be learning all about basic skills, like tools to use, how to identify rocks, and some helpful tips when you're working out in the field. So, grab your notebooks and get ready to learn. Let's get right into it. First, let's talk about tools. You're going to need some basic tools when you're working out in the field, or at least someone who has those tools. The first tool I want to talk about is this, a rock hammer. Now if you look, you'll notice the pick end and a blunt end. That's important. Personally, I have a 22-ounce Eastwing rock hammer. Eastwing is always your go-to for geology tools. If you look closely, you'll notice it says the pick end is for prying only. And that's a real important tool tip there. This is not made to be struck with. In fact, it's dangerous that way. How it is made is to be pried. Let's say, for example, you're out at a sandstone clearing and you want something on the wall. Well, assuming it's a wall you can take from, you take your rock pick, put your safety glasses on, have your rock pick upside down, go in, and pry out. Pretty simple. You also notice I mentioned safety glasses. That's important. This thing shoots little bits everywhere, and they can hurt. So it's real important that you always have your safety glasses on you. The next tool you might need is a hand lens. I don't have mine on me currently, but this is what it looks like. The 10x 21mm hand lens is the one that I recommend, and it's the one you're going to find most geologists using. Quite nice little tool, and it can get you some pretty clear vision into what you're looking at. A quick little tip before we get into that section later is when you're working in the field, you're not really going to be doing new discoveries. I know, sad, but hey, it's part of the deal. What you'll really be doing is backing up previous evidence and working on previously known sites. It's part of the deal, but hey, you gotta do it sometimes. And it can still be really fun. Imagine you're out with your friends, have a hammer, and look, you find some nice new rocks, some pretty new minerals in it that you get to keep because the place you're working for already has this. Honestly, a pretty good deal. Now, with the understanding of tools, we can talk about rock identification. Rock identification really isn't that hard. All you need to know is the basics. We're going to use igneous rocks, my favorite, as kind of our key when discussing rock identification. Igneous rocks are formed when magma cools. Now, that magma can erupt in two different major ways, either effusively on the surface or intrusively below the surface. Depending on how the magma erupts, either effusively or intrusively, the rock will have smaller or larger crystals. Effusive, smaller; intrusive, larger. Let's take a look at this basalt here. Besides the large agates, which is from a different process, the base rock doesn't really have large mineral structure. It's small, which tells us that this was effusive. A second way to identify igneous rocks is based off the color. Typically, the lighter colors in igneous rocks are reserved for higher silica rocks, or higher silica minerals, sorry. An example of that is something like granite. Granite is pink, and that comes from a mineral called potassium feldspar. Really cool, look it up. That is a very high silica rock, very high silica minerals, therefore lighter colors. And that entire family is called the felsic magmas. The other family is mafic, which is what basalt is. And another rock, which I have, gabbro. Gabbro here is a intrusive mafic rock. It's highly weathered, but if you look closely, you can see darker colors and larger crystals, which would mean it is gabbro based off of this handy chart I made. Now, if you're looking at this chart, I know, scary. There's two things that we're not talking about here: pyroclastic eruptions and intermediate magmas. We'll get to that when we talk about the Cascade Range. The next major rock group is that of the sedimentary rocks, pictured here. Sedimentary rocks can be defined by two major features: how well sorted it is, basically the congruity of the substance that it is made up of and what the actual substance is. For example, this here is sandstone, and this here is shale. Sandstone is, shocker, comprised almost entirely of sand. However, it does have other things in it, which means it's less well sorted. While this shale here is just primarily mud and silt, hence why it's also called mudstone and siltstone. But if you notice, it's not very filled with anything else like the other one was. So we call this well sorted. When talking about aging of rocks, these are some of the most useful ones, your sandstones and your shales, because of how common they are. Additionally, limestone, which I do not have a sample of, but I will one day. And when talking about aging, watch Lesson 2, Steno's Principles, for relative aging. The final group we'll be talking about is that of the metamorphic rocks, pictured here. This here is a piece of gneiss, which is a metamorphic rock. This is made from, I believe, andesite, the specific one. I could be wrong, though. Metamorphic rocks are rocks that, under immense pressure and heat, change into something else. For example, this is our shale from earlier, but if I were to compress it and put it under a moderate amount of heat, it would turn into a very thin piece of stone called slate. Now, with the understanding on rock identification, here are some quick tips to use when working out in the field. My first major tip is to be safe. Wear sunscreen, wear your safety glasses, because the safer you are, the longer you can go rock hounding. Secondly, be respectful. This is not a space just for you. You're out in the world, you're out in environments that can be delicate. So take only what you need and make sure it is a safe take area to begin with. Additionally, don't disturb paths or make new ones, especially without permission. It's a dick thing to do, and it can get you in a lot of trouble. Additionally, other people like me want to go hike those places. Last, like I mentioned earlier, look up your specific state laws and where you are getting your sources from. Places like Oregon have a very specific regulation on how many pounds you can take per day per person of rocks. For example, Oregon is 25 pounds per day per person and 250 pounds per year, plus or minus one piece, whatever that means. Now, with all this information, you can go out into nature and explore to your heart's content. Do remember, be safe, be respectful. This is other people's spaces as well. Additionally, another little guide I have is to bring a notebook with you and just jot down what you see. It's always great to have a catalog of what you find, where you find it, and help discuss your findings with other people. Now, with that, thank you for watching, and rock on.